All right, so we're going to talk about solving exponential functions. And there's a couple different strategies when you are looking at solving exponential functions. And the one we're going to talk about today is called the one-to-one strategy, or I've called it the same base strategy. And what this does is it works in some cases when you can figure them out by hand or when a logarithm isn't needed. There will be some cases where the same base strategy doesn't work, and we will learn about that later in the chapter, but today we're going to focus on problems that can be solved using the one-to-one or the same base strategy. And exponential equations require a new strategy because we haven't been solving equations where x is in the exponent. So that's what makes these different than other ones that we have been working on. So here we go. We're going to use this strategy where the goal is, if this side is 3 with an exponent, we want this side to be 3 with an exponent. Or basically we want to rewrite the terms so that both sides have the same base. So an option would be 3 or 2 or maybe 4 or something, so that you have a nice small base, same on both sides. So this side is already 3 to the x plus 1. So I don't have to make that 3. It already is 3. What I'd like to do is rewrite 9 so that it has a base of 3. So I have to think of something that equals 9 that has a base of 3. And that would be 3 squared. 3 squared equals 9. So all I did was replace 9 with something that equals 9 so that I have a 3 on both sides. If I have a 3 on both sides, I can actually cancel out my 3's or disregard the 3's and only focus on the exponents. So I can take out the 3's and say, make 2 equals x plus 1, make that my equation, and then solve it. So the same base strategy gets rid of the fact that the x is in the exponent, gets rid of the 3's, takes everything and makes it a normal equation that we can solve. So in this case, x would equal 1. We'll try it over here. This side already has a small base, so I'm going to stick with the 2. On this side, I need to think of 2 to the what equals 16, so that I can replace 16 with something that's equivalent. So 2 to the 2 is 4, 3 is 8, 4 is 16. So 2 to the 4th is 16. Got my 2's on both sides, can cancel out my 2's, and now my new problem is x plus 2 equals 4, and I can solve that. So my final answer is x equals 2. With the last one, if you see that 1/3 is over here and you want to make 81 be 1/3 to the something, that is actually more complicated. What I'm going to do is I'm going to see that there's a 3 here and see that this is a multiple of 3 and try to get 3 on both sides. So 3 to the 4 is 81. So that's going to be my 1 over here, my replacement over here. And when you have a 3 on the bottom, it's actually 3 to the 1, right? Because you can add an exponent of 1 to anything. And what I'd like to do is move this 3 to the top level so that it's not sitting on the bottom of the fraction. And when you move levels, the sign of the exponent changes. So 3 on top becomes negative 3. So if you type, negative 1. 3 on the bottom becomes 3 to the negative 1 on the top. If you type in 3 to the negative 1 on your calculator, it will equal 1/3. So one equivalent number I can use for 1/3 is 3 to the negative 1, and I get that by taking the 3, moving it to the top. Now, the 1/3 is in parentheses, so I'm going to keep the 3 to the negative 1 in parentheses and keep my x out there. Now I have my bases. I can cancel out. I've got 4 over here. With an exponent with another exponent, you multiply. That's a rule of exponents, so I get negative x. I'll divide both sides by negative 1. So in this one, x equals negative 4.